Hello, class. Welcome back. Thanks for sticking around. I know that the last couple of weeks have been kind of rough, so I'm hoping that your health is taking priority and your family is safe and you're safe as well. What we're going to do is we're going to continue on. We're doing part 3 of week 2. We're going to be reviewing the Google form answers that I sent out on Sunday night or Monday morning. And the idea is it's derivatives on trig functions. We're going to continue this kind of pattern where we go 3 videos or 3 activities a week, kind of a thing, but try not to inundate your inbox with a bunch of stuff, because I know it can get overwhelming sometimes. So, but let's jump right in. I got about 5 problems from that Google form that I want to go through. I kind of put them in order here. So let's just kind of jump in and we'll go through each derivative. All right, so first problem here. Sorry, got a little small here. It is a product, so we have to do product rule in this particular problem. So we're going to do the derivative of the first, which is 3x squared, times the second. Well, the second is cosine of 3x plus 1. So that's the first step of that. Now, since it is a product rule, you have to add the derivative of the second. So the derivative of cosine is negative sine of the 3x plus 1 times the derivative inside the parenthesis, which is 3. And then you have to take that times the first, which is x cubed. So there you go. That's the entire problem. That's the entire answer. Again, it's the derivative of the first. So let me get rid of my markers here. So it's the derivative of the first times the second plus the derivative of the second times the first. That's the product rule. All right, let's move on to the next one. So this is second question here. We're doing a product rule again, so hopefully this will make a little more sense now. So the derivative of the first, which is cosine of x, times the derivative inside the parenthesis, which is 1, times the second item. So that's the first part. Now we add the derivative of the second. Well, the derivative of the second is the derivative of tangent. Should be secant squared or 1 over cosine squared, however you want to say it. I'm going to just say it's secant squared. I think that's the easiest one that we've used. And then we take it times the derivative of the inside, which is 1 again, and then times the first, which is sine of x. So there's your entire derivative. Again, going through the rules here, it is the derivative of the first times the second, derivative of the second times the first, and we add them together. Okay, let's move on to the next problem here. I'll switch up the colors again. All right, so this one is the sum and difference rule, so we're just going to do them separately. So we're going to do the derivative of the front and then subtract the derivative of the back. So that's just, we just separate them with plus and minus. All right, so derivative of tangent, well, we just said that one a little bit ago, was secant squared of x, the whatever's in the parenthesis, times the derivative of what's in the parenthesis. And then we're going to use the subtraction symbol. Now we just do the derivative of cosine in the back. Well, that's a chain rule, so we have to drop the power out front, subtract 1 off the power, and then we take it times the derivative of the inside. Well, the inside is cosine, so the derivative of cosine is negative sine of x, and then we take that times the derivative of the inside of that parenthesis, which is 1. Again, why this works out this way is that cosine squared of x is the same thing as writing cosine of x, and then the entire thing is squared. So that's the reason why I'm writing it the way that I did here, is because I dropped the power up front, subtracted 1 off the power, so it's 2 cosine, and then we take it times the derivative of the inside of the parenthesis, which is the bracket, which is the derivative of cosine is negative sine, and then times the derivative inside that. So it's a chain rule that just keeps going. All right, let's go to the next one. We only have 2 problems left here. All right, sorry, this one got really small. Wow. Okay, so let's zoom in here. All right, so here's what we have. We have e to the tangent of 4x. I'm going to write this a little bit bigger. I did not realize how small that was. E to the tangent of 4x. And the tangent of 4x is in the power. So let me zoom out here and I'll write that down again. So e and in the power tangent to the 4x. Okay, so when we take the derivative of e, normally you go the natural log of the base times, the exponent with the same power, right? So that's just normal rules for e, but then we take it times the derivative of the power. Well, the derivative of tangent is secant squared of whatever is inside the parenthesis. That's the derivative of tangent. But then we also have to take it times the derivative of what's in the parenthesis, which is 4. That's the entire thing. Now, I know that we can simplify this. Like this natural log of e cancels out. That just makes 1. We have the e, to its power, that's the same, but then the derivative of the power itself is the secant squared, or 1 over cosine squared, if you want to write it that way. So that's the entire chain rule. That's the entire answer right there. All right, let's move on to our last problem of the day here. Last one, we have a quotient rule. So quotient rule is the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So this one can get a little tricky here. So we're going to do the derivative of the top. Well, the derivative of cotangent, if you don't know, the derivative of cotangent is negative cosecant squared of whatever is in the parenthesis times the derivative of what's in the parenthesis. So that's the derivative of cotangent. It's negative cosecant squared of whatever the item inside the parenthesis is, times the derivative inside the parenthesis. And now we're going to take that times the bottom, and then we're going to subtract the derivative of the bottom. Well, the derivative of sine is cosine of 2x, times the derivative inside the parenthesis, which is 2, times the top, which is cotangent of 2x, all over the bottom squared. So sine squared of 2x. And that's your answer. I know we haven't reviewed those properties for tangent, cotangent, and whatnot. Those are things that I'll submit on the actual link to the website. When you find this video, I'll have a picture of those derivatives one more time so you can see them. All right, that's it. On Monday or Sunday night, I will submit out another kind of activity for the week. I think we're going to go on to antiderivatives and talk about areas under curves. I think that'll be our next major topic. Hopefully you're well. Again, if you need any help or anything on some of these problems, don't be afraid to email me or call me. All right, have a good day and take care of yourself.